or high-stress conditions exist because of working in adjacent seams, roof falls can disastrously reduce the speed of advance of an expensive, highly mechanized long wall face. And roof falls are dangerous. But today we have a new aid in our continuing attempt to improve strata control, the wooden reinforcement dowel. Last year, nearly 500,000 dowels were used in British mines, most of them on face repair work. The principle of this type of reinforcement is simple. First, drill a hole of the required length. Then insert a number of capsules containing a resin separated from a catalyst. In unfractured conditions, a 6-foot hole takes 3 capsules. More are required where the strata is fractured. Finally, offer the sharpened end of a hardwood dowel to the hole and rotate it through the capsules. The resin, here coloured yellow, and the catalyst, coloured blue, are released to form an intimate mixture. The advancing rotation of the dowel ensures that the hole is backfilled around it, along its entire length. In minutes, the dowel is firmly bonded to the coal and strata. This dowel-resin combination has a considerable strength in tension. Tests at the Mining Research and Development Establishment have shown that the bond of dowel and resin can resist a pull of 10 tons, only 7 tons less than the ultimate resistance of a standard National Coal Board steel roof bolt. The advantages of this strong, cuttable dowel are readily illustrated by the animation of different face repair techniques. Not so long ago, advancing beneath a bad roof involved the laborious spiling of bars. The cutter-loader could foul the bars in passing, and nothing could stop the formation of fractures ahead of the face. The bars would often bend, and the roof collapsed to the coal head. The steel roof bolt was an improvement. Set at an angle to the face, it helped to bind the strata ahead. But its effectiveness was reduced by the difficulty of anchoring it and setting the bearing plate in fractured strata. And the steel bolt could not be set below the brow edge or horizontally into the coal, because the cutter-loader would then foul it in passing. Today, we have the wooden reinforcement dowel. It can be set in the path of the cutter-loader. It is cuttable. While the steel bolt is only secured to the strata at its 2 extremities, the wooden dowel is bonded to it along its entire length. Now, by using wooden dowels inclined into the roof above the coal and inserting others up to 8 foot in length directly ahead into it, overlapping them where necessary, it is possible to regain a good roof with a minimum loss of time and production. Poor conditions on a long wall face at Dowden Colliery equipped with IFS supports. A fault passes along the face. The immediate roof is falling to the coal head. Timber is set above the powered supports to maintain some degree of face control. Holes have been drilled into the roof and coal so that reinforcement dowels can be set before taking a cut. In this case, 4 capsules of resin and catalyst are tamped home in each hole. The dowels are inserted and rotated through the capsules. After the first cut, a brow edge has been formed. The forward spring cantilevers of the IFS supports are now under the new roof horizon ahead of it. Roof dowels are still in position. Coal dowels have been cut by the passing machine. Another row of dowels has been set, with a view to reinforcement of the roof ahead. A second shear is taken. The depth of the new roof is gradually increased. The improvement extends along the face line. Further shears follow. The dowels are overlapped until the whole face width is finally secured. A simple principle. A hardwood dowel rotating in a hole in order to mix resin and catalyst and centering itself forms a continuous bond between itself and the surrounding strata. Simple enough, but to make it work we must observe some equally simple rules. If the dowel is not rotated as it pushes through the capsules, this is what happens. Pure resin is pushed ahead into existing fractures or drawn back along the hole. The skin of the capsule is not destroyed. The bond between the dowel and the surrounding strata is discontinuous and weak. The dowel must be rotated as it is pushed into the hole. If the cartridges are not pushed to the back of the hole, the air trapped as the resin and catalyst mixture forms a seal will force much of the resin back out of the mouth of the hole. The dowel itself may even be forced back out of the hole. This dowel, withdrawn from heavily fractured strata, shows the importance of inserting sufficient capsules. The roots of resin-filled fractures can be clearly seen. Enough capsules must be inserted to fill any such fractures. Furthermore, the internal dimensions of a hole will vary slightly according to the strata in which it is drilled. The precise number of capsules to ensure backfilling of holes must be estimated on site. The wooden dowel can also be used to control floor heave. When steel bolts are used, their anchorage and clamping points are very localized. In heavily stressed weak strata, they are of little reinforcement value, since the strata may flow around the clamping plates or lift the bolt unit with it as it heaves. Roadway repair dinting cannot be done by machine, since the steel bolts are not cuttable. Firing necessitates hacksaw cutting of the bolt rods, a slow and time-wasting process. Wooden dowels, because they grip the surrounding rock along their entire length, have a much gentler and less localized reinforcing action. Should floor heave occur, it is reduced in severity, and dinting can easily be carried out by a machine, which simply cuts through the dowels it meets. The dowel lengths left in place continue to offer a measure of reinforcement. In floor doweling, it is important to drill a hole 6 inches longer than the dowel to be used. Loose drill chippings left in the hole could prevent the dowel being inserted to its full length. In any case, the loose chippings should be tamped down before the capsules are inserted. If chippings become mixed with the resin, the bond will be weakened. Where it is necessary to leave a clear floor, the square end of the dowel can be easily knocked off. For face repairs, whenever reinforcement of the roof side or floor is necessary, and where the strata may be cut subsequently by machine, the wooden reinforcement dowel will meet the case. It is the only unit available now. It is cheap, light and effective. The wooden dowel makes possible strong but gentle reinforcement wherever it is needed. Its use can make our mines safer and more productive. This is why the use of the wooden reinforcement dowel increases all the time in British mines today.